This is the 1st of April 2013. We're at Vincent Corporation in Tampa, Florida. We're running a test for Nestle. We have a drum of material here which we've rolled around to mix the dry stuff on the top with the wet stuff on the bottom. We're running it in a CP4 press. Yeah, go ahead, feed some in. Fred is going to make sure we don't get a bridge over the screw. That happens in a smaller press. Notice the screen is spitting. You'll see press liquor jumping out. That happens with coffee. It's a characteristic. It'll happen in any coffee's press. Here you can see the cake coming out. As soon as it stabilizes, we're going to start a capacity test. We're collecting the pressed liquor in a pail and the pressed cake in a pail. And we're set at 2 atmospheres pressure. We're running 2 atmospheres pressure on the air cylinder. I'm going to set this down so we can start our timed test. This is our timed test. We're less than a minute into the test. We're collecting the pressed liquor and the pressed cake. We'll run moisture analysis and consistency in the pressed liquor. We're making sure it doesn't bridge. The screw is running at 28 RPM. The main thing is 2-bar pressure. The slot width on this screen is 0.4 millimeter. About 17 thousandths of an inch. In contrast, the other press we're going to use here, a little bit larger, a CP6, has a tighter screen, 0.25, 1/4 of a millimeter, 10 thousandths of an inch. Okay, we're getting near the end of the test. We've run almost 10 minutes, 15 more seconds, and we'll have 10 minutes here. You can see the level in the bucket. We're getting ready to run the test here. Incidentally, on that last CP4 test, we got about a 50-50. The amount of cake in 10 minutes was about equal to the amount of pressed liquor. This press has dual air cylinders pushing in a cone. You can see one in the other air cylinder. Here's the cone. The screw is in operation. And if I close this cone, again, we're going to run this test at 2-bar, the same as the last test. Okay, Bill's going to start feeding material in. And go ahead, Bill. This is a 2/3 pitch screw, so that material is being conveyed into the press here. We don't see anything yet. Okay, we're starting to get some liquor here, so this cone in a little while will start to open. Now at the beginning you get some water out. That's because the material against the cone has not been squeezed by anything. This is all empty, so there's nothing to squeeze the liquid up there. So it's very wet here at the start. Now, sure enough, I see some water running down from the cone. But pretty soon, it'll fill up and the cone is starting to open already. This is with 2-bar pressure. We'll dump cake for a while, get everything stabilized. We're holding the RPM steady at 19. The RPM of the CP4 was 28 RPM. We're running this one. We have both of these presses on variable frequency drives, and we've picked standard benchmark screw RPMs for this test. Now this screen is a little finer slot. You remember it's 0.25, which is 0.01210. 10 thousandths of an inch, which is 1/4 of a millimeter. So it's a little more narrow. Interesting, I don't see as much sludge coming through the screen. There's the press liquor going through. Looks pretty clean. The bottom of this pan is dirty, but So when everything's stabilized, we're sure everything is running smoothly, we'll start another throughput test. We are starting all over again on the CP6 test. I had to cancel this press as the one we were using. It did not look right. The screw configuration was the wrong one for coffee. They explained to me it was the only one we had. However, this one came in 3 hours and 20 minutes ago. It was, no, 2 hours and 20 minutes ago. It was returned from Canada. It has fittings here. That's for steam injection. This press was set up for steam injection, inline washing, and but everything else is the same. We're running the same 19 RPM. Oh, the screen slot width is the same. There, we're starting to get some liquid out. My cone is starting to open. Well, we're pressing wet liquid against wet coffee against it. But the slot width on this screen is the same as it was on the CP6. Half a millimeter, a little bit more, 020. I can see a little more coffee grounds, at least here at the start. We'll see if that persists. And there's the cake starting to come out. And again, we will stabilize the operation so that we can start a test. Well, I had wanted to finish this test today because this material was shipped on Friday and this is already Monday. However, this screw, I jumped on this press because of troubles with that one. But I didn't know about this one. It has normal compression here. See, there's no pie cutting. That is, the flights line up. That's where all the water was coming out if you look at this video. You get down here and all these other stages have severe pie cutting. That is, a pie-shaped piece along here and here, sort of a triangular-shaped piece has been cut right off of there. That's to relieve compression and prevent jamming. It also was preventing this screw from squeezing the water. Look at the degree of pie cutting here compared to down here. Anyway, that was my problem. They're going to make me a screw on the second shift. We'll get this press running tomorrow morning, Tuesday morning. Okay, we're tumbling our barrel of material. This is Tuesday morning. We're going to run this material in this CP6 press. The press was empty, so we took some of the press cake we made prior to starting time test and checking out presses. This is just press cake. And so we have filled this press with this material. Now I'm going to put in this foam as a marker. And then we will start feeding in this fresh material. When we see the foam marker come out, we'll know we have the press full of this fresh material and we can run our time capacity test. Okay, we're feeding in press cake, waiting for the foam to come out. We threw in the pieces of styrofoam as a marker. When we see that coming out, we'll start our timed test. Okay, here's the pattern of press liquor coming out. Press cake coming out. We're running our time test. We're 43 seconds into our time test. Collecting press liquor and collecting press cake. Here's the test area. There's some of the presses we've been using, and a large number of screw presses here in this test area. More or less count motors and gearboxes. These are all machines from the rental fleet used for running trials. Here's one where we're painting the carbon steel frame. All the gray material is stainless steel. Rather than shooting more video of testing, I'm going to shoot just a quick plant tour. These are flights from which we make screws. These flights get welded onto shafts. More flights. And then we have a large assortment of screws. We're in the screw department here. And here's where we have men who manufacture the screws for our presses. There's a batch of little 4- and 6-inch screw presses. Again, machines from the rental fleet. These are primarily used for testing. This is the assembly department, a 6-inch press being put together. Here's some of the screen department where they manufacture the screens for these presses. And here I see a whole large number of screw presses. We've got the frames built, but we don't have a demand for these machines yet. As soon as we do, we can put a press together in a couple of weeks. Here's the frame of a press, small one again, 16-inch, and another press. These are just presses in the assembly department. It's now Wednesday morning, third day. We have all the samples that, out of the oven. I see samples like this. This is would have been press liquor, and these samples would have been press cake, and material like this would be as received material. Anyway, we'll have the test calculated real soon. What I wanted to show you was we ran quick tests with light samples in a hurry to get results in an hour. All of these samples were run overnight at about 95 degrees centigrade. So we're careful not to burn off anything, and we do an overnight drying to be sure we're complete. For a quick result, we can find out within an hour a pretty good number with these trays. But the thing to notice is this material. Look at the particle size here. This was the Nestle material compared to a sample that I brought back from Vietnam and another Vietnam facility. Two different processors. When I see material like this, I know the press is going to be able to work better. Well, from your standpoint, material like this, you're going to have a faster diffusion, a faster extraction cycle. You also get higher yield of solubles. You'll also have more problems downstream because of fine particles entrained in the fluid. But from Vincent's standpoint, with this I know I'm going to have less interstitial water. That's the water between adjacent particles. I also know that with this material I'll have more surface area per kilo of solids. So the electron bound water, which is attached to the surface, will be greater. What it tells me is the screw press design is more challenging for this type of material than it is for this one. This is Wednesday, the 3rd of April. We're back in the assembly department. Wanted to show you a tapered shaft. Notice this shaft is small diameter here and it tapers up. That shortens the distance between the shaft and the screen. It achieves more dewatering. We're back in the screw department. Here's another screw I flashed by yesterday. Notice a small diameter tapered shaft. Again, we're tapering the shaft from small to large. And finally, what we have here is a tapered shaft for a CP6 press, starting with a small diameter and tapering up to a much larger diameter. The reason I'm pointing this feature out is it is something that is included in the proposal for the VP16 press for Thailand. This is the 10th of April 2013. We're at Vincent Corporation, Tampa, Florida. I hope you judge us not on appearances. This is the test area. It looks a lot more like a disaster area than a test area. There's a rental press that was returned to us. We did manage to get the screw apart. We can see what happens to rental machines. The test area, we ran something like 30 tests for Nestle, and there's remnants of that all over. We're cleaning out this press, a little 4-inch press, getting the coffee out of it. We're going to run this material for Permawick. I wonder if that shows up. Anyway, Permawick. And we've got a VFD to drive the press. We're going to run it normal 60 hertz, full speed, because this material looks like it'll press well. This is a very typical screw press. There's a motor going into a gearbox, driving a screw. There's the end of the screw. The screw goes into this inlet hopper, and here you see the screw turning. Pretty well, a little black coffee grounds left there. That screw will push the material into the screened area. The screen has slots. They're big on the outside, but on the inside, those slots are about 15 thousandths of an inch wide. You see the end of the screw going around. All that real coarse material is weld-applied hard surfacing. And this brassing is a discharge door or cone, the discharge cone. It'll be pushed in by this air cylinder. The air cylinder, when we hook it up, will be run off this air regulator. The higher the air pressure, the tighter the door holds the press shut, means the harder the screw has to work to squeeze the material harder to get it to force the door open with higher pressure. We're going to collect the oil in a, this is material from a test the week before last. It's not water, so we're going to put your oil in there too. That way we get rid of oil. Water just goes into the floor drains around here. You're looking mostly coffee all over the place. Anyway, I've got the material we're going to squeeze. Looks like this. I grab a fistful of it and squeeze it. I'm getting oil out. And, so a press ought to do the same thing. Here's a press with a perforated screen. See the holes there? That's coffee that we managed to squeeze through. This press has a tapered shaft screw, so it was squeezing extremely hard compared to this press, which has the slotted screen, and the shaft does not taper up to a bigger diameter. So we're getting compression in this press by tightening the pitch of the flights of the screw and by pushing a discharge cone shut to create back pressure. Okay, we're going to run the cone in and out so we can see what that action looks like. I'm glad I ran that test. Okay, there's how the cone runs in and out. Open it and pull the cone open. Anyway, we're going to run at 30 psi, which is low. I think that'll work. The test is Bill is going to feed material in till we reach stable conditions. Then we are going to swap buckets and start a time test. And Andrew is going to hold this plastic bag to collect the press cake during the time test. And that way I'll have press cake and press liquor during a time test. Okay, Bill's going to go ahead. We're leaving the cone open for the time being till we see what happens here. Some tendency to bridge, big clumps would bridge. A bigger diameter screw prevents bridging or a declumper. Oops, it's already coming out, so I'm going to run in that cone. There, I got the cone in. And we'll see when we squeeze some more. Okay, I'm getting oil out. Look at that. Yep, press is working. We're filling it up. And the press is filling up. and we're squeezing oil out as it goes along. Screw RPM happens to be 28. I'll confirm that later. The first cake is wet. You can see where it's wet. That's because it wasn't squeezed. Now we're getting some whiter stuff out. That looks pretty dry. I could run that air pressure up and try and get more out. I won't. We're getting a flow of oil. It's not draining into my bucket yet. Where's the oil going? Okay, the oil's almost there.
There it goes.
And there it's draining out and dripping into a trash bucket. That was paint that we actually managed to separate the paint.
The ink.
Ink?
Yeah, it's that yellow ink that's in those buckets.
Okay, yellow ink. We were separating ink particles. That was a weird application. This looks good. You see the cake coming out and the oil coming out. Sorry for jumping all around, but I've got a lot to do right here. Okay, we're about ready to start the test. Okay, we're 30 seconds into the test. And we'll try to get a minute out of this. That's pretty short, but this looks good. I'm seeing good throughput. The fact I don't have any oil back there is no problem. The press is working. I can tell by the color of the cake and the flow of the oil. Here's where we're collecting our sample of press liquor. It's going to be hard to get an accurate flow rate. We got 1 minute. How far? Yeah. Oh, we got time to run. Yeah, we'll get a couple minutes out of this. The bag's apt to tear forward through. Be careful of it.
I'm watching it.
We'll just open the cone. We got 2 minutes and 14 seconds on that test. And we're emptying the press now. And hey, that was good.
Hey, I thought...
Here are rental screw presses. These are sort of mid-sized machines. We have a huge rental fleet. Screens for off of rental presses with some big ones. These are flights for screws. You can see we have lots and lots of flights for screws, and we make the screws here. There's a screw department where he's grinding on a flight, welding on a screw, rotor for a fiber filter, fitting up hammers for a spreader. This is the screw department. They're supposed to be making screws here. Getting a lot of overflow work. Here's a batch of small rental presses. These have all been, they're in the rental fleet. They've been out. I can see missing gearboxes and motors, and they need cleaning up. A shredder. You know what you're looking at here? This is the cone for a couple of cones for larger screw presses. We're in the assembly department. Just mid-sized to small presses. 16-inch, 16, another 16, that one's a 10 or 12, it looks like a 6-inch press. Small stuff, rabbits going together. We hunt elephants, but I don't have any here to show you. These are all presses that are partially constructed on speculation. When we finally, when we get an order, we'll finish it off. And that gives us a quick delivery on screw presses. Well, that's a bit of video. This is the inlet part of a screw. You can see here we're starting to taper up the shaft. There's notches in the flight. That will fill with fiber and wipe the screen, making sure it doesn't blind. Notice the flights end and then start. There it ends, starts. We put a fixed resistor tooth. There's a resistor bar with some tube resistor bars with teeth bigger, go between here and here. Another stage of compression, then another gap right in between these two, another stage of compression, Anyway, this is the interrupted flight design. Finally, we get to the end. The cone slides in and out on this portion of the screw, and this is where you saw the cake coming out of the screw press. Wind up this, we're in the lab area, and I don't have anything to put in an oven. This was where we dried out samples of press liquor and press cake from the Nestle testing. We can't dry your stuff out because it's got oil, and that doesn't do us any good. But I wanted to give you the results. It looked like we got 30% by weight to come out as oil. Don't know if that's good or bad. We could try to do better by raising that air pressure. And so it was 30% came out as oil. And our flow rate was, in that test you just saw, 350 pounds per hour of material in a 4-inch press. And that scales up. We do triple that in a 6-inch press, and triple again in a 10-inch press, and double that into a 12-inch press. Anyway, we got 350 pounds an hour in a CP4 press is very good. A very minor derating off of the brochure value.